Dobar dan svima, dobrodošli na iduću prezentaciju u ovoj sekciji. Govorit ćemo o stanju AMD GPU drivera, sad ću se prebaciti na engleski. So, we'll be talking about state of open source AMD GPU drivers. I am Dr. Vedran Miletić from University of Rijeka, and I work as a senior lecturer at Department of Informatics, and also I develop scientific software, so technically it could run on Isabella, in computational biochemistry. When I talk about computational biochemistry, I usually mean software like GROMEX that the colleague before mentioned, then NWChem, Northwestern Chemistry, Octopus, also a quantum chemistry software, very, very famous. Then we have PyMol, Avogadro, CP2K, and others. We usually talk about these programs as either using 3D to display molecules or using 2D to sketch molecules or just running some kind of simulations. In either way, we actually do have some requirements for computer systems that we want to run them on. For example, basics, right? I prefer to call them fundamentals because it's not very basic to do timings of modern monitors that are like such and such hertz, and they don't work if you do like 0.1 hertz more. So fundamentals of displays that we would actually like to, of GPUs and display drivers that we would like to use is proper display timings. We want to have mode setting that supports HD or 4K. We want multi-display because sometimes we want to display large systems on multiple monitors. And ideally, we would want high DPI, despite not of all our applications supporting it properly. On the 2D side, luckily, this has been improved a lot on Linux in the last few years. So all modern GPUs basically, instead of Exa, which was used before, use Glamour. And Glamour just does 2D over OpenGL, which works quite well actually these days. So you have the generic driver, which translates 2D calls into the native OpenGL driver of the GPU. And then on the 3D side, we are actually very, I would say we are very, we want a lot of things here. We want OpenGL, but it's not that simple because OpenGL has a legacy of 20 plus years. So 20 plus years of applications actually need to work well. We also want Vulkan, probably in the future more than today, because not that many computational chemistry applications, mostly games, run Vulkan today. And we would maybe want also DirectX to be supported, right, by our ideal driver that does all these things in open source. And finally, we also want our GPUs to do compute, right? Unfortunately, we would like to have CUDA supported because it's a very popular standard. It's a proprietary standard, so-called standard. NVIDIA wants to push it as a standard, and it usually succeeds, but it's a proprietary, so it's technically not a standard, it's just a technology. OpenCL is an open standard that is much less popular, and then we would also like some better APIs in general and libraries. So when we talk about these things, I'll just go do a little flashback to 2014 when I talked about CUDA and what's open source and what's closed source about CUDA on this very same conference. And the conclusion was basically, I didn't want to translate this slide because the content is authentic as I had it that day. The conclusion was basically that NVIDIA is leading because NVIDIA does things good. Despite them being proprietary, NVIDIA does things very well. So AMD can beat NVIDIA if they do things in open source or they do them better. Since they cannot easily do it better, they can win if they do things open source way. So in summary, I basically summarize these ideas, like how can AMD do things open source? They would need to raise the performance of the open source drivers to be comparable to Windows drivers. They would need to support OpenGL 4. Imagine how far back in terms of what we wanted were we back then when 3.3 was the OpenGL that was supported. We wanted the better compute support, and we wanted also same-day support on Linux. Just like when you buy a new Intel-based laptop, usually the thing that, if anything fails, the thing that fails isn't the GPU driver, because Intel makes sure that everything that you have in your laptop that is going to be available on such and such date is supported in existing Linux distributions that are stable on that date. So Intel actually pushes the drivers early and then the hardware comes out, which is very good. And AMD hasn't really done that. So we also talked about developer tools that would be nice to have and extensions and how we would like to hack PS4, which is actually AMD based and et cetera, et cetera. So basically, the summary of the talk, the rest of the talk was that NVIDIA was winning back then in gaming and compute. So NVIDIA was basically unbeatable, at least on Linux. I mean, on Windows, they were pretty competitive because otherwise AMD would go bankrupt. But on Linux, NVIDIA was the way to go. Intel was kind of okay for light gaming if you didn't mind the occasional crash when they used an unsupported feature or stuff like that. Compute was mostly limited to Xeon Phi, and that was quite competitive with NVIDIA, but not as good. Not as good, but they were kind of decent compared to what AMD offered. AMD was basically losing, and I actually asked, was AMD ever winning? And there was like a light laugh from the audience. Was AMD ever winning? I don't really remember. The problem was that hardware back then was quite unimpressive, so they couldn't win over NVIDIA based on hardware. They had to offer something more. Proprietary driver was just awful. I mean, when it worked, it didn't really work well. You had like game glitches, like the rendering games was severely glitched, or the game would crash, etc. And free and open source driver was way behind Windows in terms of features and performance. So for both gaming and compute, you would actually have to go for NVIDIA. Compute was basically non-existent. I mean, you couldn't even run the demos that had the sum of two vectors. That didn't even work, and that was no-go. So if you watch the trends back then, again, you would see that AMD's market share was actually declining. So I was glad that the market was responding. I hope this wasn't just the Windows users. And if you asked people, they would tell you anecdotal stories like, in 2010, I tried a 1.5 or 2-year-old card, and it was hanging with random hangs on just normal 2D desktop. Or in 2011, I bought a card which had absolutely no 3D support on the day that I bought it, and I bought it like 3 months after it was released. Or in early 2012, I noticed that AMD came out with a new card that had neither 2D, neither 3D, and just nothing very, so you just have the text console on the newest AMD GPUs. Or when I already was giving up on a salvaged AMD Kaveri GPU, a certain series that was broken, so they marked the cores as broken, so they sell it as a lower end model. You just have crashes when it was trying to load the GPU. So AMD was all around not very well supported, and they didn't invest a lot of resources in making it better. And then a year and a few months after the talk, we had this XDC 2015. We had two guys from AMD, Alex Deutscher and Zhu, and they actually talked about how they will improve the driver support on Linux specifically. And the idea was basically this. It was formalized in December 2015, 3 months after the XDC presentation that was just for the Linux enthusiasts to get them excited ahead of time. But you know, when you have these kinds of announcements, usually they can say, you know, the company changed plans, so we decided not to do it. So I waited for a while to see whether it will actually materialize in a way that it hits the mainstream media. And it did, actually. AMD, in December, 3 months after XDC, released some code on the web and promised that they will actually start developing their driver in open source. So this is a bit of marketing. They call it GPUOpen. They say that it's unprecedented GPU control. They basically give you the open driver that you can work with directly. They give you a lot of open source software that they used to develop internally in the company. They now just give it to you. And they invite participation in developing the industry standards. So this sounded pretty well. This sounded actually pretty interesting. Let's see what they actually wanted to do. So they promised that most of their software that users will run for either games or compute is going to be free and open source software. Just like Netscape, just like StarOffice, just like VirtualBox and others, they used formerly proprietary code and they opened it up. PC game developers will get the same kind of development experience like game console developers get. You have a lot of already created parts, like you just reuse parts. That's kind of nice. Also, they promise that they will host their code on GitHub, and they will version it using Git, so you can actually see what changed between different releases. You can see who did what. They will also follow up the news releases, etc., etc. And when they say open source, they don't mean any funky custom licenses, as some companies tend to do. They don't mean contributor license agreements, as companies mean. They just mean the normal MIT license that is, very simple, very short, that we all know. Also, they promised and they delivered scientific computing libraries, and the Linux driver ecosystem actually was part of this project. So the improvements to Linux drivers were meant to be done inside of the existing infrastructure that was in Linux. So when I say the existing infrastructure, I don't mean like AMD adding their own rendering infrastructure. I mean they're using the kernel, the DRM, and Mesa and LLVM that were already part of the Linux distributions that were out there. So they actually had a lot of work to do, because Radeons, when you say Radeons, you mean like 9 generations of cards. We start roughly with the older chips, which are the ones on the left, and then the newer chips, which are called Graphics Core Next. If you're familiar with the lineup, these numbers might mean something to you. If not, then just let's say, for the sake of completeness, the GCN cards are the one that are primarily the target of these developments. What they started with was a proprietary driver that was opened, and that had installation process that was prone to failure, as I mentioned before. It was very slow to follow new kernel releases, even slower to follow the changes on free desktop standards or Xorg implementations of these standards. It crashed and it had rendering errors. On the other hand, we had an open source drivers that was working reasonably well but didn't support new cards. And they actually added a new module called AMD GPU that was supposed to be their test bed for this hybrid open-closed development model, where they have some parts in the user space closed, but most of the driver is open source. And in Mesa, they had 2 drivers, and they still have 2 drivers. One is for the older GPUs, and one is for the newer ones. Also, every GPU needs a shader compiler, which is used also for compiling the compute codes. So LLVM is used for shader and compute program compiling. It's using the LLVM's processor models to differentiate between older and newer GPUs and different generations and different professional and normal chips, etc., etc. The good thing is that it's actually developed in sync with Mesa. So if you have a reasonably new Mesa and reasonably new LLVM, they work together quite well. And if you want to mix older and newer, then you have some kind of overlap in time that you can use older Mesa with newer LLVM and etc., but not too much. So already year after we got the open driver, AMD hired people that worked on it, and there were community contributions. And during 2016, we actually caught up with OpenGL changes in the standard. So we started with OpenGL 4.2 at the beginning of the year, and then in 2016, we got 4.3, we got 4.4 and 4.5. And this is not just some kind of theoretical thing that you would like to have it just to meet some kind of Mesa matrix or some kind of standard, or you can brag about it. It's actually something that made Tomb Raider playable, or that made Shadow of Mordor not being completely black and just seeing the coat on the guy. So this actually made games that didn't work before now work. So this was a really nice improvement. And right now, OpenGL 4.6 is coming slowly because very few games actually use it. I'm not sure if there is any. And performance has been improved over the years a lot. So more focus was actually done after 4.5 was completed on performance improvements, because games needed to be on par with Windows games and running on Windows drivers. So performance improvements were a priority, and OpenGL 4.6 is just happening at its own pace. If you want the benchmarks compared to Windows drivers or compared to NVIDIA drivers on Linux, there is Phoronix. They do benchmarks all the time, so I will not show them here. On the other hand, AMD actually wanted to keep its OpenGL closed, because they had a lot of code that was outsourced, developed, and then they had some code with patents, and they had a lot of complex licensing inside it, so they couldn't open source it. They wanted to develop a new OpenGL stack inside Mesa for gamers, and this is only for their own legacy professional applications, as they call it. So they have these people that use AutoCAD and such applications that would work on Linux, you know, CAD, CAM, Kaya, and stuff like that. And these applications usually depend on certain driver versions because these drivers actually address the quirks in the application. So these drivers have very limited use. They are mostly slower than Mesa and occasionally also buggier. So you have the rendering errors still popping up occasionally. These are not targeted for gamers. The good thing is that these actually require manual installations. The other ones come with Linux distributions. So in ideal case, you just download new Ubuntu, put it on a gaming system, and you are good to go. We don't just want OpenGL, as I said, we also want Vulkan. Vulkan is a new standard. It's vendor agnostic. It's supported by AMD, ARM, Broadcom, Imagination Technologies, Intel, NVIDIA, and Qualcomm, and it's a competitor with Microsoft DirectX 12. On the other side, not the driver and hardware developers, it's supported by Valve, Sony, Nintendo, Bethesda, Codemasters, Crow Team, Sega, Square Enix, and probably others. There is some engines that are listed here. You might recognize some of them. And actually, I usually like to brag about this whenever I mention Vulkan. I'm not sure if you know this, but the first game that ever supported Vulkan was Croatian game Talos Principle, developed by Crow Team, and that was actually big news. This is on the German side that I found it, but this actually hit many media. So the first game ever in the world to support Vulkan was a Croatian game. Crow Team actually followed the development of Vulkan quite closely, so they were able to do it. But the most popular game was obviously, or unfortunately not Crow Team. I mean, all respect to them, but nobody can beat Doom, and this Doom actually works very well. And surprisingly enough, the most sought after and the most talked about Vulkan game on Linux was actually running over Wine, and it was running very well because Bethesda, until the very last moment, had a Linux version ready. So they had cross-platform code that used very, 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 very little Windows-specific features, and only in the last moment before the release decided not to have the Linux version at all. So Doom was actually running inside Wine very, very soon after the release. And Vulkan was the way to go. And the drivers actually supported it as if it was a real Linux game. Other games also appeared. F1, Tomb Raider, Dota 2, Mad Max, Serious Sam, Quake, and Quake 2 were ported to Vulkan, etc. And good thing is actually that the two drivers, the AMD's one and the community's one, actually had comparable performance and still have comparable performance and feature set. So either you get the driver with Mesa, with your Linux distribution, or you download it from AMD, you have a comparable performance, you have comparable feature set. Both actually work quite well. It's a very surprising situation that it's actually easy to recommend either of them. So Vulkan support for AMD is actually quite good, either driver you choose. But we are not done there, right? We want a bit more than that. Also in open source, we also want open source support for DirectX 9. Can we do that? Of course. When you can't beat them, is not an emulate them. But is not an emulate obviously refers to Wine is not an emulator, right? So Gallium 9 is an extension for Wine and for Mesa that adds DirectX 9 support to Wine. It eliminates Wine's translation layer that converts DirectX to OpenGL before giving it to driver. And it actually makes it run faster. There are some theories that some DirectX 9 games run faster than on Windows, and that's impressive, I would say. It works on Radeon, but not on Intel, unfortunately. DirectX 10 and 11 are also doable. When you can't beat them, you can put them into Vulkan. You cannot always emulate them. Sometimes you just need to put them into Vulkan. So you just have a bunch of DLL overrides for Wine that convert DirectX calls to Vulkan calls, and then your Vulkan driver is rendering DirectX as if it was real DirectX, and Windows application doesn't know the difference. Also works over Wine, so it's working quite well, and it has been funded by Valve for over a year because they want you to be able to run Windows games that work really nicely on Linux. And DirectX 12 same story, right? When you can build them, just put them into Vulkan again. With VK-D3D, you can do the similar conversion. So we actually covered not only the open standards like Vulkan and OpenGL, we also covered the important versions of DirectX. So I think we are pretty good with graphics side and everything, except for AMD's legacy OpenGL driver is open source here. On the compute side, we actually do want to compute with the GPUs, as the colleague before said, because GPUs can compute fast and in parallel. You do this by doing single instruction, multiple data on vectors. Sometimes you also use matrices. And of course, the application is supercomputers. You want to simulate computer networks, buildings crashing down, molecules, whatever, materials, whatever you want. Also self-driving cars, which are mostly still the area that NVIDIA is dominating, and desktop applications. If you open LibreOffice, you will notice that we have OpenGL support in Calc. You can just enable it with one click. If it works, it will be enabled. NVIDIA is obviously dominating it. CUDA is a proprietary software, proprietary technology that has been supported for like over 15 years now. Over 10 years now, and it's NVIDIA only. Some of the libraries in the stack are open source, and it's actually getting, I would say, better, but it's mostly proprietary stack. So the driver is proprietary, the libraries are proprietary that are doing the user space calls to driver conversion, and NVIDIA is actually keeping this quite tight because it's working very well for their budget. You can see how well it's working on this example. So if you look at top 500 supercomputers, the latest statistics for November 2018, you can see that NVIDIA is basically dominating with nearly 90% of market share. And when it comes to performance share, then the numbers are a bit smaller, but it's still like quite impressive. So NVIDIA and Intel have some kind of NVIDIA's monopoly where Intel is trying to fit in, but it's not working very well. So NVIDIA is keeping CUDA proprietary because it's working very well monetarily for them. In terms of opening CUDA, there has been Google's development in Clang that just replaced NVIDIA's compiler with the open compiler, but still require you to use NVIDIA's hardware because it cannot run on any other hardware. But AMD actually did some work to convert CUDA to normal standard C++ code so you can run it on any hardware, be it AMD or be it any other vendor. So you just have legacy CUDA code, convert it to C++ 17, and then with some limitations, of course, you just run it on any GPU. That's stable, that works today, and it works actually interestingly well. OpenGL is another standard for GPU computing supported by many, many companies. It's just like DirectX versus OpenGL. It's an open alternative that might not be as popular as the original proprietary thing. AMD's OpenGL stack is open source. Actually, there are 3 of them, to be more precise. The recommended one is mentioned the first, AeroCM. But there is the Mesa's one that is a bit underdeveloped, so it's very slow. When you try to run things that aren't actually quite optimized for it, it doesn't support many new features, etc. There is AMD's platform abstraction layer, so-called PAL, and it's working quite decently. And there is the new one, ROCm, which is the next big thing. So that's the recommended one. It also works with C++ 17, and it works with other cool stuff. So this is going to be converging on the third one over time. So to finish the talk, what's open? In 2D, everything that we need is open. In 3D, everything but AMD's legacy OpenGL is open. In compute, absolutely everything is open. And I would say that this is winning. This is working pretty well compared to 5 years ago. And I'm glad to take any questions you might have.
So, what doesn't work? For example, you take, if you want something open, you take Debian main, and what doesn't work on the features?
Okay, so the question was what is actually not supported yet, what doesn't work yet. that depends on the particular game or particular application that might be broken. But you have so many testers that call themselves testers, but they're just enthusiastic gamers that test things on or let's say play games on a regular basis. So gaming side is actually quite well tested. On the compute side, you need to be aware of the limitations of the software that you use. For example, when you convert CUDA applications, there are limitations. You cannot use dynamic parallelism, so kernels can't launch newer kernels. But I mean, most of the things that don't work are actually documented limitations. And you're free to contribute and fix anything that, you know, that is missing. Yes?
CUDA is backed by a large community and a lot of books and materials of all sorts. What's it like with AMD?
Okay, so I don't think that OpenGL will actually go anywhere. So OpenGL is just these 5% of the applications that are happen to support it. But I would say that the way forward is C++17, which offers much nicer syntax than CUDA, and is going to be improving with compilers getting better and better. So what it would be backed by is the legacy of C++ books and C++, you know, references and forums, etc. So this could actually compete with CUDA. And you have to be aware, if in case you're not, that NVIDIA is actually locking down on the data center. So if you try to deploy GeForce in the data center, you can get sued by NVIDIA, because NVIDIA limits the installation of the driver and CUDA toolkit on a mass scale, like more than a few nodes, to only Volta, only like the Tesla cards and Quadro cards. So you need to buy professional cards to be able to legally put them in a compute cluster. You're not allowed to put the consumer cards legally, technically you can, into a compute cluster that you want to build. So NVIDIA is actually doing, I would say, a pretty bad business decision, because the moment that happened, we had a group in Stockholm trying to reach out to Intel and AMD. How can we better support their GPUs so Gromax becomes more attractive to run on Radeon and Xeon Phi? So NVIDIA actually feels the heat of users leaving its, you know, leaving the clusters and not being willing to buy Tesla if they don't need Tesla. Yes.
In background and compiles basically to native compute for AMD, right?
Okay, so the question was, how does this HIP work in the background? Does it use LLVM and does it compile into native code? So yes, it can use LLVM and it can use any other code. Actually, GCC recently got support for AMD GCN architecture. So if GCC also supports C++17, that means that GCC can also compile code for AMD GPUs. So the compiler doesn't really matter here. It's no longer the specific vendor's compiler. It's just standard-based, you know, like C++17. And if you support the architecture, any compiler can be used.
So there will be no, or AMD is not expecting any huge advancements in the GCN, you know, instruction set.
Oh, okay, so okay. So the question is whether the GCN instruction set will advance or change in any way. That's a good question. I think that the next generation is going to be the final GCN architecture card. So when the card after that comes out, the chip after that comes out, it's not going to be GCN anymore. So it will need a new backend in GCC and LLVM, and it's going to be completely separate instruction set, and it's going to be a separate story. Okay, I think we are done with time. We can discuss it later outside.
Okay,